accessing the first and the last element of a list, like we did in the last example, was perfectly easy when we knew ahead of time how long our list was. However, in many programming applications, we may not actually know how long our list is ahead of time, but Python has a built-in function for this that's going to actually help us to easier access the last element of a list as opposed to its first element of the list. And that built-in function is the length function. So as you can see in this example, len is the function, and what goes inside the parentheses, the argument that we pass to the function, is the list that we'd like to know the length of. If we then ask Python to print the length of the list called months, it would output an answer of 12 for us. Notice that although we index the elements of the list months by the numbers 0 through 11, what's returned to us from the length function is actually the number of elements in the list, which is 12. From this, if we wanted to access the last entry in the list, not knowing a priori how long that list was, we could go to the list name, in this example, months, and we could use the square brackets to access the last element of the list, which would be the length of the list minus 1. Now that notation is a little bit cumbersome, but it fits a little bit more with the syntax of other programming languages. However, Python has a really excellent feature, which is that it allows us to use negative index values to read in from the end of the list. So more simply in Python, I could access the last element of a list by trying to access its negative first entry. That will have the exact same effect as what we have written in line 2 here. And we can extrapolate and take this further. If I attempted to access months at -2, Python would simply take the second to last entry in the months list, which in this example would be November. Sometimes we want to access more than one element in our list at a time. Sometimes we would like to access what's called a slice of the list, which is some sort of range of indices that are important to us. We can do this modifying our square bracket accessing notation with the following syntax. We give the name of the list, we use the square brackets just like we would be accessing an individual element, and what we do is we actually give 2 indices to the computer separated by a colon. What this will do is create a new list, namely a sublist of our original list, and the list that we create begins with the value inside of our original list at the starting position, and this index is actually included in the process, and then our new sublist will contain all the values inside the original list up to, but not including, the value in our original list at the ending position. So examples for this are quite helpful. Going back to our months example, if I wanted to look at months starting at 5 and ending at 8, this would include the 5th, 6th, and 7th months, but not the 8th month, as is demonstrated right over here, June, July, and August. And remember, the 5th month is as the computer would think of it, not as we would think of it. There's an extra nice feature again that Python allows us, which is that each one of these arguments is actually optional. So what I've shown in this second example over here is what happens if I omit the ending position. If I omit the ending position, Python defaults to assuming that what I want to put in the ending position is the last possible value, or the length of the list. So if I ask Python to print months from 8 colon, and then I leave this option out, it assumes I want to go all the way to the end of the list, and it prints me everything from September to the end of the month's list. And a similar thing would happen if I omitted the first position, but put a value in the second placeholder. Then what would happen is that Python would assume that I mean to have a 0 here, and it would start with the very first entry of my original list and stop one shy of this ending position. Another feature Python has, which is unlike some other programming languages, is that a Python list can contain anything that we think needs to get grouped together, even if the data types of the individual objects in the lists are different. In some other programming languages, you can only list things that have the same data type, and this is not so in Python. So this is referencing the thing I referenced as a quote-unquote natural group of things. Some programming languages would find the list of objects that I have right here as entirely unnatural because I have a mix of different data types in here. My first element is a string, my next two elements are integers, then I have some more strings, then I have some floating point values, another integer. Some other programming languages would not allow this because of the mixed data types in my list, but Python is 100% okay with this. Additionally, Python is entirely fine with me reassigning or updating values in the list while also changing their data type. As a quick example we'll work through now, which we'll work through more in future slides, we can reassign values within a list using our accessing notation, and we can change the data type without any problems being caused in Python at all. So for example, if I wanted to go up to the list I've defined here and change the last value in the list from 17 to 17.5, the way that I would do that is I would give my list name, I would access the last element in the list, and I would reassign a value of 17.5 to that position in the list. That technically changes the data type of this object from being an integer to now being a floating point value, but Python has no problem with this at all, and if I ask it to print my new list after making this change, this is the output that it will give me.